Can you see the screen?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay. Okay. In the last class, we started discussing greedy search and A-star algorithm. Do you remember? What's the difference between these two?
Ma'am, greedy search just chooses the node with the like with the best heuristic value that it has currently.
Okay.
Whereas A star search, it does a combination of both heuristic value and the the cost to travel to that node. Both it takes both
Yes.
into
Yeah.
consideration.
Yes, exactly. The only difference is this f of n function. So f of n equal to h of n in best first search or greedy search. Actually, these two, greedy search and A-star algorithm, comes under best first search. So if the f of n is equal to h of n, then this is greedy search. If f of n equal to h of n plus g of n, then that is A-star algorithm. So both comes under informed search, that to best first search. So we can solve this problem. Can you note down, because when you solve in the class, then only it is very easy. If I show you the answer, then it's not possible for you people to solve during your exam. So for your exam, I stop with this A star search. Actually, tomorrow I'll start with Minimax algorithm, game playing algorithm. That will not be in your in Cat 1. I thought of completing that also, but already we have set the question paper. So this up to A star algorithm. Okay. So we'll solve this today. Can you draw this in a piece of paper? Otherwise, following this is very tough. If you simply see the values in the slide, then it's tough, I hope. Is it okay? I don't know how many of you are following my words. I don't know, but it's my duty to tell you. Please draw this diagram.
Yes, ma'am. Yes, ma'am.
Yes. S is the root node and E is the goal node.
Ma'am,
Yes.
ma'am, these numbers showed in with the letters or nodes are is the heuristic value, right?
Yes, yes. Inside the node you have some values, right? For S it is 10, A it is 9. These are heuristic value. And the numbers which are in square, that is the path cast. Heuristic values are given inside the circle with this node itself. Have you completed this?
Yes, ma'am.
Yes, ma'am.
Is copied, right? So we will start with yes, we will first complete the greedy search first. Okay, your root node is S. Then initially when you start processing, this root node S should be in open list, right? Site is in open list. When you identify its successor nodes, then it will be moved to the closed list. In some textbook, instead of open list, it is given frontier, and for closed list, it is given expanded node. So for this S node, you have three options A, B, and C. Which one is best? Because we are talking about greedy search, we need to consider
B.
only the heuristic value, right? So B. And so in every step, we need to check whether it is a goal node or not. In B it is not a goal node. Then B will be S will be moved to closed list. Yes, once you identify the successor values, the particular node will be moved to the closed list. Now in open list, you have A, B, C. Out of these three, the heuristic value is 7 for B, so B will be taken into consideration for the next step. Then we need to find the successor of B. So when you find its successor, you have two options, right? What are they for B?
D, D and H.
D,
D
yes,
and
D and H. Already you have A, B, C, and now you have D and H. When you process D and H, obviously B will be moved to closed list. Can you follow this?
Yes, ma'am.
Yes. Okay. I'll scroll down and I will show you the steps for this. Actually, this consists of the right side you have A star algorithm. Now just see the left side alone. After completing this, we will move to the right one. So initially, the open list consists of S and H of n value is 10. Okay, this is given in your step 1. Initially, closed list contains nothing because we started with the initial node S and its heuristic value is 10. Now we need to identify its successor. When you identify its successor, obviously the particular node S will be moved to the closed list. Can you follow step 2A?
Yes, ma'am.
Yes. You have,
Yes.
yeah, you need to write the successor of S. You have A, B, and C, and their heuristic value is also given. And in 2B, they are reordered. Why they reordered? Based on the heuristic value, you need to find the best node to traverse. So A is 9, B value is 7, and C is 8. So based on the heuristic value, in ascending order, the nodes are arranged. So that's why in step 2, you have two subdivisions, 2A and 2B. 2A is for finding the successor of node S, and 2B is for arranging the nodes based on their heuristic value. So with this, the least one is B. Okay. So the meaning is after S, we need to take the node B. So we'll move to the step 3. See here. So when you have B will be moved to the closed list. And what are the successor nodes of B? You can refer your diagram. That's why I asked you to draw the diagram in a paper. So what are the successor nodes of B? It is D and H, right?
Yes, ma'am.
We should
Yes,
not
ma'am.
remove A and C from the open list. It should be there. Don't remove A and C. So out of these A, B, C, B consists of the least value of heuristic. So we moved B to closed list and we need to write the successor values of B. They are D and H. This is step 3A, and step 3B, we need to arrange these open list nodes in ascending order. See here. So for that, you have to consider all the 4 nodes. Even though we are processing the successor of B, we should not ignore A and C. They are also present in open list. So you have to consider A, C, D and H. Based on the heuristic value, arrange them. Can you follow step 3B?
Yes, ma'am.
Yes,
So,
ma'am.
okay. So which one is the best node to traverse now after S and B?
H.
H. Okay.
H.
H. What are the successor of H? Refer your diagram and tell me.
F and G.
F and G. Okay.
FNG.
Yeah. C4A now. Hope it is visible to you. Step 4A. So when you find the successor of H, H should be moved to closed list. So now H is moved to closed list in step 4A, and we have the 2 successor of H, F and G. What should be the step 4B?
Reorder the open list again.
Yes, because we have 5 nodes now. So G is the least one. G should be the top. So I'll show you the step 4B. Okay, can you follow this?
Yes, ma'am.
Yes. Okay. So now G will be moved to the closed list because G is the least heuristic value. And what are the successor nodes of G?
E. Gold node.
E goal node. Yes, only one node, right? Only one node. E is goal node. And that is in 5A. So when you move G to closed list, you need to write its successor. We have only one successor node for G, that is E. Always this the goal node consists of 0 value for its heuristic. Okay. In any problem, for all other nodes you have some value, but for the goal node it is 0. Sometimes nothing will be given for the goal node. From that you need to identify. Can you follow this? If heuristic value is not given for a node, then we need to assume that is the goal node. Normally they will mention what is the root node and what is the initial node and what should be the goal node, but heuristic value will not be present, or sometimes 0 will be given for the goal node. Now E is the least value, so we need to rearrange it as per the previous step. And in 5B, you have E in the top because it has lesser heuristic value. So you need to, there is no successor and the heuristic value is 0, then obviously it will move to the closed list. So for every step, we need to check we need to perform the goal test. What is goal test? What is goal test? So in every step, we need to check whether we reach the goal node or not. Because when the problem definition itself, we have the initial node, goal node, and successor function, everything is given to you. So when we are processing or when you are traversing the tree or searching the graph, we need to perform this goal test. So now the exit condition is satisfied, or you can say we have reached the goal node. So it is moved to the closed list. So the path is S from S to B, B to H, and H to G, and G to E. Can you follow the path from the root node to goal node in greedy search?
Yes, ma'am.
Yes. So why the name greedy search? Because it is considering only the heuristic value. There may be some other path with lesser cost. So you have some values in the square, right? The edges have some weight or cost. There may be some other possibility also, but this algorithm will not consider any other value other than the heuristic. but it is very fast. It is very fast. So that's why the greedy search approach is used in certain application. Whenever we want the solution quickly, we can go for this greedy search approach. So, okay, this is 6A. That's it. So we have completed the greedy search approach. So in the right side, we have A star algorithm. Actually, this is tough, right? Compared to greedy search, A star algorithm takes longer time and it will take more memory also, because for everything we need to consider the heuristic value and also the best path from the root node to the current node. So we will solve that. So when you compare these two, so this A star algorithm is best. It will give you, it will maximum, it will try to give the optimum solution, but it is not as easy as your greedy search. No need to consider the weight or cost associated with the edges or the distance from a node, from a pair of nodes. It is not in greedy search approach, but when you have A star algorithm, you need to consider the value and you need to consider the distance from the distance between the nodes also. So shall we start solving this?
Yes, ma'am.
When that the previous one is very easy. Okay, now the first step is same, because initially see the difference in right in the left side. For step 1, we simply consider h of n, because f of n equal to h of n in greedy approach, but here it is not like that. F of n equal to g of n plus h of n. H of n is the heuristic value which is given in the node itself. So in this example, the node is represented as a circle. Within the circle, you have the node name and its heuristic value. And what is g of n? G of n is the distance from the root node or the initial node to the particular node n. So initially we started with s. So g of n is obviously 0. H of n is 10. It is given in the problem itself. Yes or no? So f of n equal to g of n plus h of n, it is 10. Okay. And we will move to step 2. Okay. So for S is the root node. Refer your diagram, then only you can understand it. A, B, C are the successor nodes from S, isn't it? And their heuristic values are 9, 7 and 8. So this is same like your greedy search. You can refer in the right side, so left side, so that you can write in the right side also. And the g of n value is distance from the root node to the particular node. So for A it is 7, for B it is 2 and for C it is 3. Is it correct? 7, 2 and 3.
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
yeah. Yeah, 7, 2 and 3. Now calculate f of n. So f of n, you need to add these two, right? G of n plus h of n. So for A it is 16, B it is 9 and C it is 11. Okay, so in open list you have 3 nodes A, B, C and their f of n value is calculated now. So f of n is calculated based on the heuristic and the distance from the root node S. So what is this step 2b? We need to reorder them. We need to reorder them. So see step 2b, because node B consists of 9 and C 11 and A it is 16. So which one we need to take? Which node should be moved to closed list?
B.
B. Again B, right? So B will be moved to closed list and we need to find the successor of B. So now after root node we have identified the successor nodes. So this is very simple. After that we need to find the successor of B. What are the successor nodes of B?
D and A.
D and H. D and H, right? Okay. So D and H you can write the heuristic. And now what is the distance from root node to D? root node to D, root node S to D. You have two options, right? Now what is the distance from root node S to node D?
6.
Actually, you have 6 and 11. You have two options. When you go through A, it is 7 plus 4, 4 it is 11, right? When you go through B, it is 2 plus 4, it is 6. So which one we need to take? 6, because G of n is the least distance from the root node to the node n. So for D, it is 6. And what about H? You have only one option. 2 plus 1, it is 3, right?
Yes, ma'am.
Okay. So for D, it is 6 and for H, it is 3. So we will refer step 2B. Sorry, 3A. Step 3A. Can you follow this? Already we have A and C in our open list. Already open list consists of these two values C and A. Now we have identified the successor of B. Successor of B node is D and H, and you can copy the heuristic value from the diagram itself, but when you calculate G of n, you need to take the best path or the least cost path from the root node to the current node D. So you have two options, 6 and 11. We need to choose 6, and for H only one option, it is 3. So you can add the G of n and H of n value and you get the F of n value for D and F of n value for H. Can you understand this?
Yes, ma'am.
So what's the next step? Reordering them. Okay. So when you reorder them, again the node H consists of lesser value F of n, it is 9. So obviously it should be moved to the closed list. Okay. Then H will be moved to the closed list. So what are the successor nodes of H? From diagram
F
we
and
will see.
F and G.
Okay, F and G, for that you have only one path from the root node, right? S, B, H and F. So what's the total value? 2 plus 1 plus 3, it is 6. 2 plus 1 plus 2, it is 5 for G, isn't it?
Yes, ma'am.
Okay, so that's it. Yeah, in step 4A, you have the G of n value. For F, it is 6 and for G, it is 5. So again, calculate the F of n value by adding G of n and H of n. Then in step 4B, we need to reorder them, right? So when you reorder them, which one consists of a least value of F of n? Node G. Can you follow, ma?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Okay. In step 4B, so it is G. So again, G will be moved to closed list, and the successor of G is E, right? Successor of G is E alone, and G of n value is 7. So we'll find the distance from root node to E. I'll go to the diagram. Root node to E. 1, 2, 3, 4, 5, 6 and 7. Because from root node you have the path S, B, H, G and E. So when you add the actual cost, it is 7. So and the heuristic value is 0 here. Okay, so the least, when you add them, finally you get F of n value. So when you reorder them, again E will be in the top. So before moving every node from the open list to closed list, we need to perform this goal test. If it is a goal node, then that goal test will return you the true value. So with that, we can stop the process. Can you understand the two methods?
Yes, ma'am.
Okay, and one more thing, fortunately for this example, the path is same, S, B, H, G and E. Fortunately for this example, S, B, H, G and E. This is the path. You can refer the step 6A. So from root node S, B, H, G and E. This is the path obtained by both the methods from root node to the goal node. In some cases, there may be more than one path, or maybe two or three paths from a node to the goal node, or from the initial node to the particular node. There may be more than one or two options. So in that case, you will get different path from the root node to goal node. Anyway, in some problems, this A star search will give you less number of steps than the greedy approach. The one more thing is it will give you the optimal solution, and the greedy search will not consider whether it is optimal or not. It is very fast. The very big advantage of this greedy approach is it is very fast. So it don't consider the distance between the nodes. Based on the heuristic value, it simply proceed with that particular steps. It will check the heuristic value alone. Sometimes heuristic alone will not give you the optimal solution. So this is the comparison of these two methods. So you will be given with any diagram like the example which is given here. Sometimes the heuristic value may be represented within the circle, that is in the node, or it may be given as a separate a table, or sometime the value is written near to the node. So you need to assume that the particular value is the heuristic value. Mostly you will be asked to compare these two algorithms, because no need to write procedures and I think, but you can write the steps like this. Okay.
So, ma'am, we don't need to move the first node in the open list to the closed list, right? We don't need to write stuff like that.
Yeah, no need to write like that. You can use this kind of table format also. Anyway, we need certain steps, right? We need to understand how you process. So
So, if we
this.
show the state of the table at each point, then is that enough?
Ah, yeah, that is enough. That is enough. That is enough. Yes. Even here it is given 6A, 6B, 5A, 5B, because every time you need to update the table. When you reorder them, the notes, the content of the table will get changed, right? So just write. I think this representation is good, which is given in this slide, because no need to explain in words, because you have open list and we have closed list. In step 1, it consists of only initial node, and in step 2, you have its successor, and in step 2A, you have the successor. In 2B, you need to reorder them based on the heuristic value. So this representation is easy. Otherwise, which you can refer net in Google, you can find some other option also. Whichever is comfortable to you, you can follow that. So in the third module, you get this any one problem from this A star and greedy approach in third one, and in second unit you have the search space and uninformed research. You have 6 different searches, right? Best first, depth first, depth limited search, and iterative deepening, bidirectional and uniform cast search, and some maybe some statements will be given to you. You need to justify them. For example, iterative deepening is good for which kind of scenario? So like this, you may be given with some statements. You need to justify them. because every algorithm or every search method has its own advantages and disadvantages. So for that you can refer the material since it is an open book test, and you need to give the proper example for that. And in the first module, some agent type will be given to you. You need to write their PEAS notation, right? What is PEAS notation? Performance measure, environment, actuators and sensor. For example, if it is vacuum cleaner, we have these 4 parameters PEAS, which we have already discussed in the class. So like this, you may be given with some agent name. For that, you need to write the PEAS notation. And types of agents are there, right? Model based, goal based agents, and you have different types of environment: static, dynamic, deterministic, stochastic. So for that, you'll be asked some statements will be given to you. For that, you need to justify your answer. Okay, ma.
Yes, ma'am.
Okay. So up to A star algorithm, you have for your exam. Tomorrow I'll start with minimax algorithm, but that is I didn't ask any question from that because I'm not sure whether we will complete that in tomorrow's class. So then tomorrow is the last class, so I skipped that part for your question. So game playing, I'll start game playing tomorrow, minimax algorithm. So after completing minimax, we have alpha and beta broning. So that will take time. So that's why I skipped the topic for your cat 1. But these two, A star and greedy search approach, it comes under your module 3. Okay. Okay, ma.